This video is on proportional relationship. Let's start by writing down the definition of proportional relationship when you're looking at data in a table. So in a table, if both quantities increase by the same factor, and factor means you multiply, then it is a proportional relationship. Let's look at this table. If I ignore the zero quantities and start with where pounds equals 3, if I go 3 times 2, that would give me 6. And then the other quantity, if I go 7 times 2, that would give me 14. Again, if I go 3 and then go 3 times 3, that would be 9. 7 times 3 is 21. So you see that each time I'd be multiplying each quantity by the same amount. Therefore, this is going to be a proportional relationship. 7 times 4 is 28. 3 times 4 is 12. So that's what we mean by if both quantities increase by the same factor. All right, now let's consider this table. Okay, let's ignore the 0 and the 5, and let's go to the 1. If I go 1 times 2, that would be 2. But 6 times 2 is not 7. 6 times 2 would be 12. If I go 1 times 3, that's 3. But 6 times 3 should be 18, not 8. So this is not proportional. We can't multiply each quantity by the same amount. Another definition of a proportional relationship is on a graph, a proportional relationship is linear, okay, so it makes a line, and it goes through the origin, 0, 0, right there, okay? So the graph has to go through the origin and be linear in order for the relationship to be proportional. And if we graphed the data in that table that we looked at, that's exactly what it would do. Here's the graph of the data that we determined was not proportional. Notice how it is linear. Okay, that does make a line, but it does not start at the origin, at 0, 0. So again, as this shows by our definition, that graph is not proportional. Here we have 4 different tables. Go ahead and examine each table carefully, determine which ones are proportional, and if any, which are not. Pause your video and then restart to check your answer. Welcome back from pausing the video. Let's look at that first chart right here, hours and money. If I go 1 times 9, that's 9. 2 times 9, that's 18. 3 times 9, that's 27. 4 times 9, that's 36. Okay, if I go 1 times 2 and 9 times 2, it gives me the same number. 1 times 3, 9 times 3. 1 times 4, 9 times 4. This is proportional. Multiply by the same number for both quantities. Let's look at this one. If I go 1 times 2, that gives me 2. 15 times 2 is 30. If I go 1 times 3, 15 times 3 is 45. 1 times 4, 15 times 4 is 60, not 90. So it looked like it was going to be proportional, but that number right there, that 90 was off. So this is not proportional. Here I go 2 times 2 is 4, 8 times 2 is 16, 2 times 3 is 6, 8 times 3 is 24, so we would say yes. this last graph, 100 times 2 is 200. 35 times 2 would be 70, not 45. 100 times 3 is 300. 35 times 3 would be 105. So this is also not going to be proportional. Okay, so the first one was yes, then no, yes, no. Now let's check out each of these graphs. Determine which ones are proportional and which ones are not, if any. Pause your video, then restart to check your answer. Welcome back from pausing the video. Well, I can see that this first graph is linear, but it does not pass through the origin, so it does not meet our definition of proportional. Here, I have a linear graph that does go through the origin, so this would be a yes. Here on this graph, another linear graph, but it doesn't start at the origin, so this would be no. And finally, this one, it does go through the origin, it is linear. That's a yes. That's all for tonight. Remember, read some books.